Hello friends, welcome back to our channel Physics and Animation. Here in this video, we are going to talk about the working of permanent magnet moving coil galvanometer. What is galvanometer? Galvanometers is an electromechanical instrument used for detecting and indicating an electric current. It is a sensitive electromagnetic device which can measure low currents even of the order of a few microamperes. Galvanometers works as an actuator by producing a rotary deflection in response to electric current flowing through a coil in a constant magnetic field. Now let's talk about the constructional detail of the permanent magnet moving coil galvanometer. Permanent magnet moving coil galvanometer is made up of a two concave permanent magnet, where magnetic field is directed from north to south, and rectangular coil that has many turns, usually made of thinly insulated or fine copper wire, is wounded on a metallic frame, which is pivoted from both the ends. The coil is free to rotate about a fixed axis. This whole arrangement consists of two phosphor bronze hair-like springs. The first one is connected to a upper pivoted free end of the coil, and second spring is connected to the bottom pivoted free end of the coil, and both of these springs are fixed from the other end by the help of a binding screw. A cylindrical soft iron core is symmetrically positioned inside the coil to improve the strength of the magnetic field and to make the field radial. There is a very important reason for keeping the magnetic field radial, which we will talk about later in this video during the working of a galvanometer. Also, the pointer is mounted on a pivoted coil for measuring the angular deflection in the coil, and two ends of the coil are connected to the two terminals of the galvanometer. Principle of permanent magnet moving coil galvanometer. Permanent magnet moving coil galvanometer works on the principle that current carrying coil placed in a magnetic field experiences a torque. When the current is allowed to pass through the coil, current starts flowing from A to B in the left arm of the coil and from C to D in the right arm of the coil. As we can see in the animation, that in the arm AB, direction of the current is upward, and in the arm CD, direction of the current is downward, while the direction of magnetic field is from north to south for both the arm AB and BC. Therefore, according to the left hand Fleming rule, two couple of forces or torque starts acting on a coil, which will help in rotating of a coil and causes angular deflection of the pointer. At this time, hairspring comes into play and creates counter torque to resist any extra unnecessary deflection or damage of a very sensitive pointer, and always ensures the proper functioning of the galvanometer. Corresponding calibrated scale is provided for converting the angular deflection of a pointer in a microamperes. Now let's try to understand that why this radial magnetic field is needed. Here we have used concave shaped magnets to provide radial magnetic field, but why? Let's explore it. As we all know, equation of the torque in this case is NIAB sin theta, where N represents number of turns, I is the current, and theta is the angle between the magnetic field B and the area vector, which is always normal to the plane of the rectangular coil. It's very clear that sin theta for an angle of 90 degree is always 1. Let's move to the top view and try to analyze it. Now we can see that because of the radial magnetic field, for each and every positions of the coil, magnetic field and the area vector are at right angle, or theta equals 90 degree. Therefore, Radial magnetic field provides constant torque irrespective of the rotation of the coil. This makes the deflection directly proportional to the current. Because N, A and B was already constant and now theta also becomes constant, that's why. Now current I is the only variable, which makes it easy to calibrate the instrument for the measuring purpose. Thanks for watching friends. Please don't forget to like our video and subscribe to our channel so that you will be notified whenever we upload a new video.